Right.
Good morning, students. As we know, in class 12, activities are an important part in our practical exam. We have 6 activities, 3 from section A and 3 from section B. One of the important activity of section B is class lab. Let us see here on this sheet that what is the aim of this activity. It is to observe refraction and lateral deviation of a beam of light incident obliquely on a glass slab. Apparatus required are a sheet of white paper, glass slab, drawing board, 2 thin needles or office pens, scale, pencil, etc. In the theory part, let us see the diagram which we are supposed to do, and that is, let us look at this. We have a glass slab. Now it's my choice that whether I should keep it lengthwise or breadthwise like this, and after making the boundary of the glass slab, I am going to make a normal. Normal is to be with a dotted line, sharpened pencil to be used, and then this angle of incidence from this normal is to be either 30 or 35. I am preferring to have 35 degree as the angle of incidence between incident ray and the normal. Now I will be putting 2 pins here, 2 office pins, and putting the glass slab back to its position and looking from this side. When I will look from this side, I will put 3rd and the 4th pin so that all the 4 pins are in straight line. Okay, in the straight line when I am looking from the glass slab. So I will complete the ray diagram and will find out the lateral displacement which I will measure in this case, as well as with the angle of incidence as 45 degree, I will find the lateral displacement. I can have one more diagram which is like this. I can make it breadthwise and keep my glass slab in this position. Again, be careful when you make the normal. Take the normal to extreme left side so that the angle of incidence is formed here, again 35 degree, and the ray after refraction will go like this and like this. If I take this point in the middle, it might not give you the correct reading. So please be careful for taking this reading to the extreme left. So put the glass slab back, put 2 pins here to do different positions, put 2 pins here and make a complete ray diagram. Again take the angle as 45 degree, put 2 pins here and then see from this side you will get the ray diagram where lateral displacement is to be found. Now after doing this part, we have to substitute the values of our result in this reading table which is called observation table. I am taking along length, along breadth. These are 2 different parameters. Angle of incidence at first along length 35-45, along breadth 35-45. Now angle of emergence should come out to be 35 and 45. Here also 35 and 45. Whatever lateral displacement I am having, I will record it here in centimeter. Now wait for the conclusion. Let us perform an experiment, find the readings here, and then I will discuss the conclusion with you. From 1.2 centimeter to 2.1 centimeter. Okay, now looking to the other case. In this case, when I have taken the glass slab in the other order, the angle of incidence is same, 35 degree, and lateral displacement is found to more. It is 1.7. Why it is more? Because the ray is traveling more distance in this glass slab. It has covered more distance because the glass slab is placed along breadth. Similarly, when I take 45 degree angle here, the lateral displacement is coming out to 3.1. So if I record all the readings in observation table, it is like this. Yes. So the angle of incidence is equal to angle of emergence in any case. You can see that. And lateral displacement is varying because the angle of incidence is increasing. So 1.2, the angle of incidence has increased to 45. It is 2.1. And in another pair, the angle of incidence is 35. So lateral displacement is coming out to be 1.7. And in the last case, when the angle of incidence is 45, it is coming out to be 3.1. So very easily we can conclude our result. The ray of light emerging from glass is parallel to the incident ray and is laterally displaced. The second conclusion is the lateral displacement of the emergent ray increases with the increase in thickness of the slab. Also, we can say that the lateral displacement of the emergent ray is bound to increase with the increase in the angle of incidence, keeping other factors same. So this is the whole scenario. We have to record our readings like this. Thank you.